So we'll continue looking at separation techniques. So last time we talked about methods of purification or methods of separating different substances, and we talked about how to separate a solid from a liquid. So when you have got a solid liquid mixture, the methods we can use to separate this, the first method we talked about is filtration. So you should be able to draw and label. They can ask you to draw and label the process of filtration. Okay, the other one is decantation, and then the next one is sedimentation. Okay, so these methods you are able to see, you are going to separate a solid from a liquid. So for filtration, you are going to separate a solid from a liquid. Now the solid should be insoluble. Okay, so you say insoluble solid and a liquid. So actually all of these which are here, you separate insoluble solid and a liquid. What we mean by insoluble solid is that the solid should not dissolve. For example, when you have got sand and water, sand does not dissolve in water, so it is insoluble. Or even meal does not dissolve in water, so it is insoluble. Now when you mix sugar and let's say water, sugar or salt dissolves, so you will not use filtration. You are going to use another method for that one, right? So let's talk about that. Now, what of if you want to separate a soluble solid and a liquid? Now, what we mean by soluble solid is a solid that dissolves. Okay, you want to separate it from a liquid. For example, I have got water in a cup and then I put sugar there. So what I'm going to have is a sugar solution. So I've got water plus sugar, that forms the sugar solution. Now I want to separate so that I'm going to have the sugar and the water alone. So what we are going to use is an evaporation dish. That's a method you use to separate a soluble solid from a liquid. Evaporation dish. So how is this set up? There is a dish that you get, like that, is something like this. I'm going to pour this liquid. So we are going to put it on.
Question.
Yes,
Did you say that you are going to put water, sugar,
yes, water and sugar.
and what will be happen?
So if you have got water and sugar, you are going to form a solution if you mix them. Okay,
Uh,
all right. So here we are going to put a tripod stand, something like that. And then we're going to get an evaporation dish. So I'm going to have a candle or any source of light. I'm going to put a source of light here. So this thing is burning, okay? It's burning like that. And then I'm going to get an evaporation dish. I'm going to put it here. And then, so this is what we're calling as an evaporation dish. And then I'm going to get the solution, the sugar solution. I'm going to pour it on here, right? I'm going to pour it here. So what is going to be happening is that this is going to start evaporating. So we're going to see evaporation happening. Evaporation is going to be happening. So this is going to be happening slowly. So when that happens, the water would have gone. So the water has gone, and then what will just remain here is the sugar itself. Or if it was a salt solution, what is going to remain is salt itself. Or the water has gone. So this is how you separate a soluble solid and a liquid using an evaporation dish. Okay, is this okay?
This is okay.
All right. So apart from separating a solid and a liquid,
What that's called preparation.
yes, that's evaporation happening there.
Okay.
So you can also separate two liquids. So what if you want to separate a liquid from another liquid? Okay, we've talked about methods of separating a liquid from a solid. What of a liquid from another liquid? Now we have got different liquids, okay? We are going to start with what we call immiscible liquids. Immiscible liquids. Now, what are immiscible liquids? Immiscible liquids are liquids which do not mix. Okay? Liquids which do not mix.
Okay.
And an example that you can give is when you have water and cooking oil. Those do not mix. So liquids which do not mix are called immiscible liquids. And for immiscible liquids, the method you are going to use to separate them is a separating funnel. Okay, separating funnel. That's the method. So you are going to use a separating funnel to separate these two liquids. Now, how do you get to prepare a separating funnel? So you are going to have, let's have a stand. Okay, this is a stand here. And then we are going to connect this funnel, something long like that. Okay, so something like this. At the end here, we are going to close there. And then down, you are going to have an opening. You're also going to have a tap down. So I'm going to have a tap here. So the aim of the tap, this is where I'm going to be opening. Okay, like that. That's a tap. So now the question is, how do you get to do this one? So what is going to happen is that you have got two liquids. Now when you mix water and cooking oil, water will always be down. Okay, so you are going to have water down here. They'll bring also this in the question, they ask you to label. So this is water down, and then you are going to have now the cooking oil, and that one is going to be on top because cooking oil is going to be a little bit of mm,
You're saying that you water with cooking oil. So how can you mix it with water with cooking oil? You still have to add salt in the water.
so because these two liquids they don't mix. You've seen the oil is on top, right? And then the water is down. They are not mixing, so that's why we are calling them immiscible liquids. Okay. So
Okay.
what you are going to do is this tap you are able. This is a tap. So what you are going to do is you are going to be opening that tap, right? So this thing here is a conical flask. So when you open the tap, you should be like you are also looking at the way the liquid is dropping. So the liquid is going to be dropping. The water is going to be dropping here. Okay, the water is dropping like that. So when all the water has dropped into the conical flask, you close the tap. When you close the tap, only the oil is going to remain, and that oil is going to remain in the what? In the separating funnel. This is the separating funnel. So when you do that, you have separated a liquid from another liquid. Okay, so basically that is what you get to do. A separating funnel is simply an apparatus used to separate a mixture of two immiscible liquids. So the denser liquid is going to be down. This is the denser liquid. And then the one which is on top is a less dense liquid. That one is less dense. So the liquid which is less dense is the one that you are going to see in the funnel after the denser liquid has poured away. Right. Is that okay? Is that okay?
Yes, it's okay.
All right. So basically this is how we separate a liquid which is immiscible from another liquid. Now, we also have some liquids which join completely. Okay? We also have some liquids which are able to join completely. Now, how do you get to separate such liquids? So so those liquids which completely merge, or those which mix completely, we call them miscible liquids. Miscible liquids are liquids which mix completely. Since those which do not mix, we call them immiscible, so these are going to be called miscible. So what are miscible liquids? These are liquids which mix completely. All right. And then how do you get to separate these? So to separate miscible liquids, there are different ways that you are going to be able to talk about. Okay, there are different methods that you get to talk about on how to separate them. And here we're going to talk about distillation. That's the most important method that we are going to use. Now, I'm going to start by talking about just the distillation itself, or we can call it as a simple distillation. Simple distillation. Now, when we are talking about this kind of distillation, simple distillation, this one you are going to separate different things. For example, you have got a common one you are going to see. You have got copper 2 sulfate. You want to separate it from the water. Okay, now an example that I'm going to give for this one is when you want to separate water from potassium manganate. You can also separate water from copper 2 sulfate. Okay, so you want to separate water and potassium manganate. Please, in the exam, if you see water and copper 2 sulfate, it's the same. You are going to use the same simple distillation. Okay. So potassium manganate 7, that's the one you want to separate. So how is this setup? So again, you need to know the setup, because at times they'll just bring this setup. They ask you, I mean, they can either bring, they ask you to label, or they are going to ask you to draw and label the method that you are going to use to separate water and potassium manganate, or water and copper 2 sulfate. Please, you need to know this method. Okay, so the setup also something like that. So this is just a stand which I'm putting here. I want to draw as you are seeing, instead of me just drawing in advance, so that you get to see how you are able to also draw it in case it came like that. And we are going to be labeling it together so that when they bring for you to label, it will not be a problem. Okay. Okay, so what I've put here, I've put a round bottomed flask. This thing you are able to see here, it is called a round bottomed flask. You can see because it's even round there. Okay, so we have connected it to the clamp. Now this thing, the clamp, is just there to support the round bottomed flask, because if you put it alone, it is going to fall, and if it falls, it's going to break. So at the end here, we're going to have an opening at the end of the flask here. Again, at the opening, I'm going to connect a pipe, which is going to go like that. Okay, and then here we are going to put a stopper. We are going to put a stopper here so that there will be no evaporation of anything. The liquid do not evaporate and go out there. Okay, so that's why we get to put that stopper. And then at the end, I'm going to put, you can put a beaker or just anything this side. It's all up to you. So let me just put something that okay, we are going to put it like this. And then we've placed it, you can just put anything here just to make sure that you place the beaker so that it is supported, right? And then also here we are going to put now a condenser, and this condenser is going to have two openings. One opening is going to be here, another opening is going to be on top here. Please take note of that, very very important. Okay, we are going to close here. To just support this condenser, we are going to also put another clamp to just support it so that it doesn't fall. So that is where it's going to be supported so that it does not fall there. And then also here we get to connect that so that it is not going to be able to fall. Right? So this is the apparatus that you are going to see in a simple distillation. Now let's label what we have here. Of course, here we are going to have fire which is burning, which is heating up the liquid which is there. So we have a fire here. And what you are going to see is that the liquid which is here will start. So you have got a liquid, and that liquid is a mixture. You have got a mixture of water and the same potassium. So water plus potassium manganate 6. Okay, you have got the water and the potassium manganate. So I've written the formula, but that's the name potassium manganate there. I've just written the formula down. All right, so what you are going to see when the heat is, as the fire gets much hotter and you are getting to heat up this liquid, the liquid will start to do what? It will start evaporating. It will start evaporating. And since it cannot come out from this end, what is going to happen is that it's going to go here. Now for this point, you have got This point you have got cold water entering. So cold water goes in. Please take note, it's in. And then at this other end on top here, you have got uh, they are going to have hot water leaving.
As a question,
Yes.
um, when you just put hot water, then you're supposed to have a steam from there when it comes out from hot water.
So here you are going to have the cold water that you are putting. Now remember, this vapor that is coming here, this vapor is hot. Okay, that's a vapor, it is hot. So when you put in cold water here, like you've put in cold water here, this vapor that is going to be passing here is going to make this water hot. So you have to remove it, and you are going to remove it this side. That is why you are removing hot water. Alright?
Okay.
Yes. So this is what we are going to see. Now this condenser here is not just any type of condenser. It is a Liebig condenser. Liebig condenser. Okay, please. If they ask you to name, state Liebig condenser. Don't just say condenser. Okay, so this liquid, when it reaches this point, when it reaches in this tube, this point here, it will no longer be vapor. So at this point, it is vapor. When it reaches there, it will no longer be vapor, because when you make vapor cold, it's going to turn into a liquid. So the process by which a gas changes into a liquid is called condensation. Okay, so the water is going to condense, and when it condenses, it's going to start dropping as a liquid. It's going to drop as a liquid here, and what you are going to see in this beaker is the water. So the water is going to come here, and this is going to be called, because this water has been collected after distillation, is going to be called a distillate. So in case it came in the exam, mention the liquid in the beaker. It's called a distillate after distillation. If it was after filtration, it is called a filtrate. Okay, and then what is going to remain now in the beaker, I mean in the round bottom flask, you are going to have now the solid potassium manganate remain here after all the water has moved. So this is a process of simple distillation. So the water is going to boil and evaporate, forming vapor, leaving behind potassium manganate in the round bottom flask. The water vapor is now going to pass into the condenser, where it is cooled and turns back into liquid water, which drips into the collecting beaker, so into the beaker. So water is separated from the potassium manganate solution using this method. Okay, so this process is distillation, actually simple distillation. Alright, so the color of the solution in the distillation flask is still the same, or even dark after heating has stopped, because potassium manganate does not distill. The colorless liquid collected after distillation is called the distillate. So at the end, you are going to have the distillate, and this is going to be colorless. But in here, the liquid is not colorless. It is going to, because when you mix water with potassium manganate, you are going to have the color of the potassium manganate, which is something like dark blue, something like that. Okay, so that is what you're going to have. But at the end, you're just going to have water alone. Is this okay?
Yes, it's okay.
Alright, so this is a process of simple distillation. When you want to separate what do you separate using simple distillation? It is a solution. You separate a solution of a liquid and a solid that mixes completely, or a solid that is different from salt, or sugar, for that one you are going to use an evaporation dish because it forms crystals. But when you want to separate like potassium permanganate or copper 2 sulfate, you are going to use the simple distillation. Okay, I'm not going to rub this diagram because I'm just going to change the process. Now, what if I want to separate? So I'm going to remove this. Let's say I mixed water with alcohol. Those are also two liquids, right? Water and alcohol, they are both liquids. Now those liquids, they mix completely. Okay, those two liquids are going to mix completely. We call them miscible liquids. What method do you use? You use fractional distillation. So that's why we need to mention, because we have got different types of distillation. This is fractional distillation. The other one from talking about is simple distillation. So this method is used to separate miscible liquids. For the previous one, the simple distillation is not miscible liquids. Actually, separate a liquid from a solution. Okay, a liquid from a solution. But miscible liquid, fraction distillation is separate miscible liquids. For example, you want to separate water and alcohol. Now, these methods come a lot in the exam, so you need to know them really. Okay. Now, how is the setup for fractional distillation? Now, this setup here is for simple distillation. The only difference with fractional distillation, what you are going to see is that, pay attention, look at what I'm removing. Okay, that is going to be the difference. If they ask you to state the difference between simple distillation and fractional distillation, okay, like that, I've removed that one. You can see this is where the beaker ends. Then we are going to add another component. We have another component there. And at the end of this component that we have added, we are going to put a thermometer. So we have a thermometer at the end there. Okay, like that. And then inside this thing we're able to see, we are going to put some glass beads, like that. We have glass beads there. Okay, so we have a connection here. Okay, like that. Then at the end also we get to close there, so that there will be nothing to move out. So this is the difference. So the difference between fractional distillation and simple distillation is that we have got glass beads. We also have this thing that we have put here. This thing you are able to see here is called the fractionating column. Fractionating column. How do I label it? Let me put this side like this. So we have got a fractionating column, and the fractionating column contains glass beads. Okay, so those things in blue which you are able to see, we call them glass beads, like that. And then this will still be water in. Actually, it's called water in, and then the one here, it is water out. Okay, this condenser is still a Liebig condenser. And then you are also going to put a source of fire here to be able to heat that. Now inside you have got a solution or a mixture of water and alcohol. Now what is going to be happening is this. You know, water boils at 100 degrees Celsius. And then the alcohol boils at 78 degrees Celsius. So what will happen is, as you get to heat this mixture, when you reach 78, because 78 is smaller than 100, okay, when you reach 78, the alcohol will evaporate. So as you heat the mixture, the vapor is going to be coming out. The function of the thermometer here is to record the temperature. That's why the thermometer is there, to record the temperature at which liquids are evaporating. So when you reach 78, you are going to see that the temperature on the thermometer will stop changing, not until all the alcohol has evaporated. So when all the alcohol has evaporated, what is going to happen is going to come here as a vapor. But when it reaches here, where there is a Liebig condenser, the alcohol again change into what? Into liquid. So we are going to collect it here. So what we are going to collect first is what? Alcohol. So when you collect the alcohol, all the alcohol has moved. You now remove. Okay, we are going to remove this beaker containing this alcohol. Now, what's the function of the glass beads inside here? Because when the alcohol is evaporating, they are also going to take some water. Some water also will be evaporating. So the glass beads are there to prevent the water from going together with the alcohol. So the water which evaporated is going to be prevented from condensing together with the alcohol. What is going to prevent are the glass beads which are found in the fractionating column. So after all the alcohol has changed into vapor and it has gone into the beaker, the temperature will start increasing from 78. You are going to see it starts changing to 79, 80. So immediately start doing that, remove the beaker because all the alcohol has changed. When you remove the beaker, put another beaker. So when you reach at 100 degrees, then the water will also start evaporating. So at 100 degrees, the temperature also will stop changing on the thermometer. When all the liquid or the water has changed to vapor, it comes here, it will also start dropping here. When all of it is dropped, you see now the temperature continue rising. So that means that all the water has changed and you only have water in gaseous form. So you would have separated water and liquid. This is how you separate two miscible liquids using fractional distillation.